So good morning, one and all. Today it is a great honor us that Dr. Meenakshi Awasthi with us. She received BE degree in Electronics and Communication Engineering from CCS University in 2003, MTech in Electronics and Communication Engineering from GCET Greater Noida in 2012, and PhD degree from IIT Roorkee in 2019. She has worked with ABES Engineering College as assistant professor for 12 years. Presently, she is working with Ajay Kumar Garg Engineering College as associate professor in the Department of Electronics and Communication, July 2019. She is supervising one PhD candidate in communication field. She is an active member of IEEE and WISE. She is also live reviewer of AEU General and Wireless Personal Communication General. Her area of research includes cognizant radio networks and wireless network. She has published 8 journal papers, including 3 SCI and 1 Scopus. She has also presented and published 4 papers in reputed international conferences, including IEEE 10Con in Malaysia and IndiaCon. Ma'am, I heartily welcome you on behalf of Poornima College of Engineering. Over to you.
Sir, am I audible?
Yeah, ma'am.
Okay. So a very good morning to one and all who is listening. So I hope this seminar is going well and you people are enjoying it and gaining knowledge from this. So few contribution I want to make through my presentation through this seminar today in terms of 5G and evolution of 6G. So, ma'am, I'm sharing my screen. Just let me know that whether my screen is visible or not. Okay. So, my topic of presentation for this seminar is green 5G and its evolution towards 6G. So my first area of concern will be, the green 5G. I mean, mainly upon the energy efficiency improvement part. And then I'll be covering a bit about, the evolution of 5G to 6G. So let me start with the green 5G first, and then I'll be covering about, for the 6G. So these are the key points that I'll be covering today. First is the introduction, 5G enabling technologies, energy efficient radio resource management, new architecture and deployment paradigm, green energy exploration, open issues and research opportunities, evolution of 5G towards 6G, conclusion and references. Okay, so let's start with the 5G. Okay, so with fast penetration of smartphone, tablets in recent years, data traffic on mobile network has increased significantly. That we can see in a day-to-day conversation and all. So 5G is supposed to support 1,000-time traffic increase in coming 10 years, with energy consumption around the half of 4G. So this leads to the requirement of a 2,000-time increase in energy efficiency. You can see that this huge amount of energy efficiency improvement is required when we want to deploy 5G in networks. So therefore, high energy efficiency is critical for sustainable development and growth of 5G networks. So energy efficiency I'll be covering today mainly. So energy efficiency has been determined as one of the key objectives of 5G systems. To realize sustainable 5G, various new technologies have been proposed to reduce conventional energy consumption. Green energy sources are explored to reduce the dependency on conventional energy. Now, also there are a lot of research going on to improvement in the energy efficiency in which radio resource management architecture and deployment paradigm is there, green energy harvesting and smart grid integration. These are the few areas which we'll be discussing and discovering today, on which we'll be discussing about the energy efficiency part. So this is the key picture which is covering the whole thing about the energy efficiency in 5G. So if we can see here, like okay, so this is the green 5G enabling technologies. Okay, so there are two ways by which we can, save the conventional energy and also to explore the green energy. So basically, two ways are there by which we can improve upon the energy efficiency part. So the first way is to, save the conventional energy, and the second way is to explore the green energy part. So first, we'll be discussing about the conventional energy saving. I mean, what are the means and ways by which we can save the conventional energy? So broadly, we can classify it into two parts. The first is efficient radio access resource management, and the second is new architecture and deployment paradigm. So these are the two broad areas in by which we can, save the conventional energy part. So going forward with the efficient radio access resource management, there are few subcategories that we have divided here, although we'll be discussing later on the few PPTs. Like first is energy efficiency and spectral efficiency trade-off, dynamic cell operation, D2D, UDN, massive MIMO, millimeter wave. So these are the areas which are there under the efficient radio access resource management to save the conventional energy. The second broad area to save conventional energy is new architecture deployment paradigm. So traffic offloading, caching and edge computing, CN assisted scheduling, CRAN and NFV. These are the few ways that comes under the new architecture and deployment paradigm part to save the conventional energy. Now moving on towards the exploration of green energy. So these are the areas, you can see these are the areas which are emerging as the research area, as the main research area in 5G if we talk about the energy efficient part. So broadly we can classify it into two parts. First is energy harvesting and second is a smart grid enabled. So energy harvesting, let me say, like this is the main area in which you can do your research. I mean, this is the area in which you can start your research if you want to research in the communication field of 5G. So energy harvesting is a emerging area. So what comes under energy harvesting is first is the environment energy harvesting and second is the RF energy harvesting. So these are the two ways by which we can perform the harvesting part of the energy, which is the green area or the green energy. Now the second part of which is coming under this explore green energy is smart grid enabled. So this is also another area of research that we can start upon. About the smart grid enabled. So this is this we can deploy with the help of a smart grid integration. So now we'll be discussing one by one about each and every area of this. So first let me start with the energy efficient radio resource management. So as you can refer that picture, this is the first way by which you can see that this comes here. So energy efficient radio resource management can be performed by first, which is the spectral efficient. Okay. So I'm sorry, there was a interruption in between. So we were discussing about energy efficient radio resource management. So the very first point that here I want to mention is the energy efficiency and the spectrum efficiency. This is very important to understand before going for the energy efficiency improvement. So this we can see here, energy efficiency and the spectral efficiency. So what do you mean by energy efficiency? I mean, what is the way by which we can calculate the energy efficiency? So energy efficiency is basically the number of transmitted bits per unit energy. So this is known as the energy efficiency. And what do you mean by spectral efficiency? So spectral efficiency is the transmission rate per unit bandwidth. Okay, transmission rate per unit bandwidth. So here I have mentioned few few equations by which you can see the relationship between data rate and energy spectral efficiency and energy efficiency. So if we talk about the AWGN channel, the achievable transmission data rate R can be given by the equation 1. So R is equals to W log 2 1 plus P upon W and naught. Okay, so this is the first equation by which we can calculate the transmission data rate for a system where um, P, W, and N naught denotes the transmission power, spectrum bandwidth, and the noise strength. Okay, so this is the first equation is the transmission data rate. The second equation represents the spectral efficiency, eta. So spectral efficiency is log 2 1 plus P upon W and naught. So with this equation we can calculate the spectral efficiency of a network. The third equation represents the energy efficiency. So it is W log 2 1 plus P upon W and naught upon P. So by this equation we can calculate the energy efficiency. Now, in the fourth equation, we have shown the relationship between the energy efficiency and the spectral efficiency. So I'll be showing the relationship and the, with the help of illustration also in the next slide. So spectral efficiency and energy efficiency can be expressed by equation 2 and 3. From equation 4, here you can see that energy efficiency is a monotonic decreasing function of spectral efficiency. So you can see from this equation 4 that energy efficiency is a monotonic decreasing function of spectral efficiency, which means that optimizing one metric is at the cost of degrading the other. So here the point comes out is like if we increase the energy efficiency, then the spectral efficiency will decrease. And if we increase, so with this illustration, you can see that we have shown for different alpha, where alpha is the coupling factor, which means the ratio between the channel with or without interference. So for different alpha, I mean 0, 0.1, 0.51, and so on, we have shown the relationship and we have shown the variation of energy efficiency with respect to spectral efficiency, where this spectral efficiency is represented in terms of bits per second per hertz, where energy efficiency is represented as bits per joule. Okay, so that I already told you, like spectral efficiency is actually the transmission rate per unit bandwidth. Okay, so that's why its unit is bits per second, which is the transmission rate divided by unit bandwidth. So its unit is bits per second per hertz, and energy efficiency is the transmitted bits per unit energy. So here from the first, red graph, you can see that if you are increasing the spectral efficiency, so at a certain instant of time, it is increasing, but after a certain instant of time, it starts decreasing. So, I mean, so here the point which the important point that comes out is like we have to find a trade-off. Okay, we have to find a trade-off between spectral efficiency and energy efficiency for a system. So moving again backward for this. So I mean, this was the first area in which we can improve the energy efficiency by taking into consideration the spectral efficiency for a system. The second is radio cell operation, dynamic radio cell operation. This is the second area in which we can do the energy efficiency. So given that the energy consumption of radio access network accounts for more than half of the overall energy consumption of mobile networks, many many work has been done to reduce energy consumption of RAN through dynamic cell operation. Okay, so the idea of this dynamic cell operation is to switch off or deactivate as much as the radio resource like antenna or carrier or beam once the user demands is decreased. Okay, so by efficiently utilizing our resources, we can improve the energy efficiency of a network. The next is energy efficiency introduced by device to device. Okay, so energy efficiency can be introduced in a network by using a device to device communication. So device to device communication means, I mean, D2D communication is the communication that directly, which is a direct communication between two devices by using licensed or unlicensed spectrum resources. So in that way also, we can, improve the energy efficiency of 5G network. Next is energy efficiency of massive MIMO. So this is also MIMO. So what is this massive MIMO? Massive MIMO means, I mean, we have multiple input and multiple outputs. So there are a number of antenna that will be there in a network in which we have the MIMO. Okay, so I mean, there are a lot of antenna involved at transmitter and receiver side. So due to that, there will be a huge energy which is consumed in the network. So by efficiently, I mean, by optimizing the number of antennas, we can improve the energy efficiency of 5G network. Next is the energy efficiency of millimeter wave. I mean, you all must know that in 5G, we talk about the millimeter wave communication. So this is another area of research in which we can optimize energy efficiency of a millimeter wave. Next is energy efficiency of ultra dense network. Okay, so this is also another area in which we can improve the energy. Again, energy efficiency on 5G new radio in 3GPP. So these are the few emerging areas in which we can think upon to increase the energy efficiency for a network. Okay, so given the emerging 5G network radio technology like full duplex, device to device communication, massive, multiple input, multiple MIMO, millimeter wave backhaul, and ultra dense network, the radio interference environment of 5G will be much more complex. Okay, so these are the few things that are involved with 5G. I mean, device to device communication, massive MIMO, ultra dense network, millimeter wave backhaul communication. So all these technologies, what actually does, they make our system very complex. So more work are necessary to develop a unified framework to have a comprehensive understanding on the balance between energy efficiency and spectral efficiency in new radio environment. So I mean, you have seen like these are the things that are that actually made this is much complex. So that's why I mean, we need to develop a unified framework to understand the balance. Okay, so this we have already discussed. So now moving on to the next part, which is new architecture and deployment paradigm. Okay. So basically it covers the traffic offloading, mobile caching and edge computing, core network assisted scheduling, energy efficiency control framework, cloud RAN, network function virtualization or NFV. So this traffic offloading is actually, it can be used to reduce the traffic from a specific RAN function or core network to improve the energy efficiency. Okay, so this is actually the traffic offloading. Now also by employing the mobile caching and edge computing, we can also improve the energy efficiency. This will be covering here. Okay, so this is the first architecture of core network assisted traffic scheduling. So in this architecture we can see how we can design the architecture of a core network, and which is actually assisted by traffic scheduling to improve the energy efficiency of a 5G network. So this is again the energy efficiency control framework, which we can design this type of framework to improve the energy efficiency of a 5G network. I mean, by energy energy efficiency policy management, energy efficiency control and coordination, energy efficiency profile management. So here you can see the flow. I mean, these are interrelated. Okay, you can see here that these are interrelated. If you are, I mean, if you are discussing about the policy management, so it should be connected with the control and coordination, and also it should be connected with the profile management. Okay, so these three are connected with this energy efficiency control operation. So here we have energy efficiency optimization entity. By energy efficiency metering, we can give the feedback to this again. So this, in this way, you can see that we can control and we can design the energy efficiency control framework for the network. So this is again the flexible radio function split and deployment. I mean, see this how much complex this network is. So this is the 5G core network, which is connected with the C plane, U plane. Okay. So this is how we can do the radio function, which will be flexible and deployable. Okay, so these are the few open issues and research opportunities. I mean, we can see here that we can do. I mean, if you want to note it down, you can do. First is the leverage the strength of machine learning. Second is comprehensive energy consumption model. Consider UE and network energy efficiency together. Emerging technology and network structure. Practical network environment and traffic. So these are the few open issues that are there with the energy efficiency improvement in the 5G communication. Okay, so here again, I want to go back with the first slide just to have a recall of this to explore the green energy. So here, this is actually new area of research. So I want to mention it here, like what is this energy harvesting and what is this smart grid enabled. So in energy harvesting, we have two ways. I mean, first is the environmental energy harvesting, and second is the RF energy harvesting. So what is this environmental energy harvesting means? So this environmental energy harvesting means harvesting the green energy from natural resources. I mean, which is actually the sun, wind, etc. So this is known as environmental energy harvesting. Second is the RF energy harvesting. So RF energy harvesting means the harvesting energy from the radio signals. Okay, to harvest the energy from the radio signals over the air, which can be transformed. Which can transform the harmful interference to a valuable source in EM based power. So if we harvest the radio, then it comes under the radio frequency energy harvesting. If we harvest the resources, the natural resources, so it comes under the environmental energy harvesting. The second is the smart grid enabled. So a smart grid, with the help of integration of the smart grid, we can also increase the green energy. So I mean, you can note it down that energy harvesting is the emerging area of research that on that we can do. I mean, we can start our research in this area. So these are the topics that we have covered for green energy. Now let me start with the 6G evolution. Okay, so what is the need of 5G towards 6G, evolution of 5G towards 6G? I mean, 5G is already covering everything. I mean, 5G is yet to be deployed. So what is the need of 6G? So 5G demonstrated the vast potential in paradigm defining techniques such as network softwarization and virtualization, massive MIMO, ultra densification, introducing of new frequency bands. So this is actually the 5G, which yet to be deployed in India, of course. Maybe in few countries it has already been deployed. So what it has demonstrated, a wide potential difference. I mean, you can see it's a kind of paradigm shift, you can see. So even it is having all these, massive MIMO and densification and a good, speed. but also there is a need of, you can see the need and demand of the market is still going on, and it's increasing very rapidly. I mean, you can see the day-to-day scenario also. You can compare it with current situation, like everybody is sitting at home, and due to COVID everybody is using virtual means and ways to have the communication, to take the classes, to attend the classes, to have online webinars and everything. So that's why you can see the need of the market. So I mean, need of the market is increasing thousandfolds. Okay, it's increasing thousandfold. So I mean, even if the 5G will not satisfy the needs and demands after 10 years. Okay, so that's why we have to think upon beyond 5G. And if we think upon the beyond 5G, 6G comes into picture. Okay, so I mean, with the help of 5G, numerous burgeoning applications and verticals were also involved, which are actually virtual and augmented reality, e-commerce, contactless payment that we have already seen, machine-to-machine communication, enhanced mobile broadband. So these are the key applications and verticals that are there, that are associated with 5G communication. Okay, now moving towards the sixth generation. So 5G to 6G. So next generation VAR. Okay, so we have already discussed about the virtual and augmented reality. I mean, most of us, we have seen also augmented reality. I mean, we have lots of numerous games also, which we can do with the help of virtual and augmented reality. So next generation VAR will be the key area of 6G. And what is this next generation VAR? Which is actually a holographic teleportation. And holographic teleportation is also known as holoportation. Holoportation. So I mean, if you are fond of movies, that I mean, you must have seen Avengers Endgame movie. So in that movie, you have seen the holographic teleportation. I mean, they communicate with each other with the help of holographic teleportation. So this is the new new emerging area of the 6G, in which we can assume holographic teleportation will be a feature of the 6G. So it requires terabits per second level of data rates. I mean, 5G gives us a data rate in Gbps. Okay, the downlink 5G data rate is approximate 1 Gbps. But here in 6th generation, we need terabits per second level of data rates. And the latency is microsecond level latency. See the beauty of 6G, that is terabits per second data rate and microsecond level latency. This will be the beauty of 6G. So with the help of these data rates and this much of latency, we can imagine the holographic teleportation as a feature of 6G. Also, increasing industrial automation. I mean, you must have heard about industry 4.0. You must have heard. But in 6th generation, we'll be discussing about industry 10.0 paradigm. So again, you can see the paradigm shift in this automation industry, from industry 4.0 to industry 10.0 paradigm. Okay, so I mean, you can see the surroundings of industrial automation. So much of automation has been done in our industry also, and so in industry 4.0 will be enhanced as industry 10.0 with the help of 6th generation. So this is also a very emerging area. If you want to start a new research, if you want to have if you want to start new research, so you can start with this industry 10.0 also. You can go for this also. So next is push connectivity density well beyond 10⁶ kilometer square matrix that 5G is designed for. Okay, so I mean, so it is beyond 10⁶ kilometer square matrix. I mean, that was along with the 5G. So the push connectivity will be the beyond 10⁶ kilometer square. An increase in connection density will also result in demand of improved energy efficiency. Okay, so while the ITU, I mean, you all must know that ITU basically design and recommend all the the specifications which we use in the wireless communication. So I mean, ITU is still working on a set of official recommendations for the KPI metrics for 5G. But actually, this topic that I am presenting here, this I have taken from the white paper of 6G from Tata. So I mean, so these are the calculations or the specifications that I'm showing here. These are the tentative values. I mean, these values are yet to be fixed by the ITU. Okay, so the tentative values have appeared in the public domain recently, are mentioned in the table. So this table is showing various KPIs of 5G and 6G. So I'm again mentioning here that these KPIs are yet to be finalized by the ITU. Okay, so although I have taken all these from white paper of Tata, so here this KPI is actually the key performance indicator. So this is, I mean, this slide will give you a brief idea about how 6G will be evolved from the 5G. So first we'll talk about the system capacity. Okay, basically we'll be discussing about system capacity, system latency, and system management. So if you talk about the system capacity, so in 5G, the peak data rate, okay, the peak data rate in 5G is 20 Gbps, whereas in 6G it is expected to have 1000 Gbps data rate. It is expected to have 1000 Gbps data rate in 6G. Okay, next is experienced data rate. Okay, I mean, this is the theoretical value of data rate that is expected to have. Now, experienced data rate in Gbps in 5G, it is 0.1 Gbps, whereas in 6G, it is expected to have 1 Gbps experienced data rate. Next, we talk about the peak spectral efficiency. Okay, I mean, we have already discussed about the spectral efficiency part. So peak spectral efficiency in bits per second per hertz. Okay, bits per second per hertz means the transmission rate divided by the unit bandwidth. So bits per second per hertz, it is 30 for 5G, whereas the spectral efficiency which we can expect from 6G is 60 bits per second per hertz. So this is the peak, I mean the theoretical peak. Now the experienced spectral efficiency will be 0.3 in 5G and 3 in 6G. Next is maximum channel bandwidth in gigahertz. Maximum channel bandwidth in 5G is 1, whereas in 6G it will be 100. Area traffic capacity in Mbps per meter square. It is 10 in 5G, whereas it is 1000. It is expected 1000 in 6G. Then connection density. Devices connection density means number of devices per kilometer square. So it is 10 to the power 6 in 5G, whereas in 6G it is expected to have 10 to the power 7. Now next is, so these are the key points that comes under system capacity. Next is the system latency. Okay, system latency. So the end-to-end latency, which we have taken in milliseconds, it is in 1 millisecond in 5G, and you can see such a low latency in 6G. So it is expected to have 0.1 millisecond latency in the 6G. A delay jitter is introduced in 6G. It is not introduced in 5G yet. So it will be introduced in 6G. So delay jitter in millisecond will be 10 to the power -3 in 6th generation network. So next, move on to the system management part. Okay, so here we'll talk about the energy efficiency. So see the unit here. It is terabits per joule. So I mean, we are not talking about GB. We are not talking about KB. We are not talking about MB. We are talking about terabits per joule. So, I mean, it is not applicable in 5G. So, I mean, terabits per joule energy efficiency is not and never expected in 5G. Whereas in 6G, it is expected to have 1 terabits per joule energy efficiency. Reliability, which is in packet error rate, it is 10 to the power 5 in 5G, whereas it is 10 to the power minus 9 in 6G. Now, if we talk about mobility, which is in kilometer per hour. So the mobility for 5G network is 500 kilometer per hour in 5G, whereas in sixth generation it is 1,000 kilometer per hour we can expect. So here we can see, I mean, we can compare the evolution of 6G from 5G. I mean, 5G is yet to be deployed in India. I mean, some part of India we have deployed already, but not it is not covered in the whole India. So I mean, 6G, you can see like there is a huge difference between the KPIs of 5G and 6G. So achieving these KPIs highlighted in the table will require revolutionary breakthrough across all the domains of wireless communication. I mean, you cannot expect like this much of data rate, this much of bandwidth, this much of energy efficiency without any effort. Okay, so I mean, you need a revolutionary breakthrough or your revolutionary research in all the area, not even a single area, in all the area of wireless communication, in all the domains. Then only we can expect this much of KPIs for 6G. So what are those areas? What are those domains in which that kind of research can be done? So the first is a new spectrum usage and radio design paradigm is required. So these are the 4 points, four key points you can see here. The first is a new spectrum usage and radio design paradigm. Of course, you will be looking for a new spectrum. Okay, and also new radio design paradigms are required to obtain such a huge KPIs, such efficient KPIs for 6G. Next is novel architecture. Novel network architectures are expected to have in the 6G. Next is increasing intelligence. Of course, I mean, we want to move from industry 4.0 to industry 10.0. So definitely your environment, your network will be much more intelligent as compared to 5G, right? And also there should be a lot of automation that should be involved in 6G. Enhancing network coverage beyond the terrestrial domain. This is also very important area of concern in 6G. I mean, in up to 5G, you will be thinking about the terrestrial communication, but 6G will be beyond terrestrial communication, and beyond terrestrial communication means the space communication. So, I mean, you have to think about the space communication also, and you have to merge it along with the terrestrial communication. Although nowadays we have separated terrestrial communication and the space communication, like satellite communication, we have separated. But there will be a merging of these two communication in the 6G that we'll be discussing later on. So what are the solutions of these issues? I mean, these are the areas, 4 areas in which we can do the revolutionary research. So what are the solutions and what are the options by which we can improve these areas and these domains? So there are so many enabling technologies and techniques by which we can improve upon under those domains. So the first is, first case is the new spectrum usage. So here in 6G, network operating at the terahertz band with abundant spectrum resources. Okay, so I mean, we have to think about the terahertz band, right? And if we talk about terahertz band, so we have to make all the devices and resources that are compatible enough to work in these bands. I mean, the type of antenna, the type of devices that we'll be connecting it for the transmitter, for the receiver, for filter, for everything. I mean, we have to do the research on device level also, because we have to prepare devices, such a devices that will work and that will efficiently work in this terahertz band. Okay, so we have to design and we have to think upon the network which will be operating at terahertz band and with abundant spectrum resources. Next is intelligent communication environments. Okay, that enables a wireless propagation environment with active signal transmission and reception. Okay, so I mean, your communication environment will be intelligent so that it enable, you know, wireless propagation with active signal transmission and reception. Pervasive artificial intelligence. Okay, so pervasive AI is also to be explored in the 6G evolution. Large scale network automation. So this is also a need of the 6G communication. I mean, you need a large scale of network automation. All spectrum configuration, all spectrum configurable front end for dynamic spectrum access. So what is this dynamic spectrum access? So this dynamic spectrum access is nothing but, I mean, if we have a number of spectrum bands which is available, and I mean, these spectrum bands will not be fixed and will not be assigned for a definite user. I mean, there will be a flexibility to access a network or a spectrum as when it is needed. Okay, so dynamic spectrum access is deployed to improve the energy efficiency of a network. Correct. So I mean, we have to think upon all spectrum which is reconfigurable front end for dynamic spectrum access. I mean, dynamic spectrum access is also a part of 5G. It will also a part of 6G, so that energy efficiency can be improved, and energy efficiency in terms of the network, in terms of spectrum usage. Correct. So I mean, if we allocate a spectrum, fixed spectrum to a user, and for a particular time, if that user don't want to use that spectrum, that in that way that spectrum will be wasted. Okay, whereas in dynamic spectrum access, if that spectrum is available which is allocated to a user, and if user is not using that spectrum at a particular instant of time, then another user can use that spectrum with the help of this DSA technique. Ambient backscatter communication for energy saving. I mean, you can see here again that along with all network designing and everything, again and again we are talking about the energy efficiency. So I mean, it's my suggestion, if you want to do research, then energy efficiency improvement is an area which never be faded. Correct, which never be faded. I mean, it is key area in 5G. It is key area will be, this area will be in 6G also, because you always need to improve the energy efficiency. Correct. So ambient backscatter communication is also required for energy savings. Next point, which is very important and very fascinated, I'm very much fascinated about this, is the Internet of Space Things. I mean, you must have heard about Internet of Things, but here in 6G, you will be discussing about a few new IoT, few new versions or advanced versions of IoT. So the first version is the Internet of Space Things. Correct. So the Internet of Space Things is nothing but it will be enabled by CubeSats. Okay, and UAVs. What is this CubeSats? What is this CubeSat? So CubeSat is nothing but a cubic satellite. Okay, which is actually a nano level architecture of satellites, which is very lightweighted, and I mean, many countries have already launched a cube satellite also. I mean, also there is a research is going on to reduce size a lot, but CubeSats will be the future of Internet of Space Things. I mean, we'll be using internet with the help of these cube satellites. Okay, and UAVs are also very much needed thing in future wireless. Okay, I mean, with the help of UAVs and cube satellites, this Internet of Space Things will be deployed. Next is cell-free massive MIMO. cell-free massive MIMO. Okay, so I mean, till now we are limited to the massive MIMO in 5G, which is related to the cell. So we'll be thinking about a cell-free massive MIMO in 6G. I mean, it will be beyond cell designing. I mean, beyond that cell limited. Okay, so these are the few areas of the 6G evolution. Again, there will be three very promising techniques that are expected to shape the future of communication, yet you will not be sufficiently mature for 6G. So these are the three very emerging technology. I mean, it will not be covered in 6G also, but these are the few three technologies, very new, I mean, state of art in wireless communication. The first is the Internet of Nano Things, the Internet of Bio Nano Things, and the quantum communication. So these are the future of wireless communication. Okay, future of wireless communication. I mean, these things we don't expect in 6G, but maybe in higher versions of 6G, these things will be seen in future. So the first is the Internet of Nano Things, second is Internet of Bio Nano Things, and the quantum communication. So this is the beautiful picture of 6G and beyond 6G. I mean, these are the very key areas and key technologies that are involved with the 6th generation. So the solid lines shows the technologies that are related to the 6G, and the dotted lines shows the beyond 6G technology. I mean, these technologies are not expected to be part of 6G, but maybe later on beyond 6G, I mean, maybe higher versions of 6G, we can expect it to have these technologies also. So in 6G, we have discussed about cell-free massive MIMO communication, cell-free massive MIMO. Okay, so this we have discussed. Then terahertz band communication. Terahertz band communication is the technology that is there in the 6G. Intelligent communication environments. I mean, every box, each and every box is a research area on which we can do our research. I mean, there is a lot of scope of research in this. You can find in this from this slide. Okay, so intelligent communication environment is also a part of 6G technology. Pervasive artificial intelligence, network automation, also required for 6G. Reconfigurable front ends oblique dynamic spectrum axis. Okay, reconfigurable front ends means the devices that are connected through a network, the front end devices, they should be reconfigurable, and also dynamic spectrum axis for the 6G. And this is for the this we use to improve the energy efficiency. Then also to improve the energy efficiency, we have ambient backscatter communication. So these two are, these two, 7 and 8, is used to improve the energy efficiency. Now to connect or to think about beyond terrestrial communication, or you can say to connect the terrestrial as well as the satellite communication, we use the Internet of Space Things. Okay, so this is also very emerging area if you have interest in satellite communication and wireless communication. So this will be a key point which is actually connecting the terrestrial communication and the satellite communication. So the Internet of Space Things is a future of 6G, which help us to connect with the space. I mean, it is actually used to think beyond terrestrial communication, and the Internet of Space Things can be used with the help of cube satellites and UAVs. Now the shaded line, we have already discussed about these three technologies that are very state of art in wireless, and that is quantum communications. And the use of these three technologies will be in the beyond 6G. Okay, Internet of Bio Nano Things and the Internet of Nano Things. So these are the three technologies, promising technologies that we can imagine beyond 6G. Now, use cases best served by 5G systems. So if you recall the 5G systems, there are three use cases that are served with the help of 5G system. So 5G introduced a the targeted use cases intended to serve a wide variety of applications. So first is EMBB, URLLC, and MMTC. Okay, so EMBB is the enhanced mobile broadband. Next is ultra reliable low latency communication. Okay, so enhanced mobile broadband means, I mean, by using this mobile with the broadband, we can also enhance the speed and the range also. Ultra reliable low latency communication, I mean, low latency means low delay. Okay, so ultra reliable low latency communication is also another use cases for the 5G. Massive machine type communication. Okay, massive machine type communication. So these are the three use cases that are served by the 5G systems. Now we'll see in this slide, you can see the use cases which are best served by the 6G systems. Okay, like the 5G, you can see the three use cases that we have seen. Now in 6G, you can see how much complex it is. So these are the use cases which are best served by the 6G systems. So here you can see the emerging use cases for 6G systems. So importantly, we can see and we can directly get from the picture is the industry 10.0, which is industrial automation, then space connectivity, then smart infrastructure. Okay, smart infrastructure, space connectivity, and industry automation, which is industry 10.0. So if we talk about this area, industry 10.0, it is related with three technologies. Okay, or it is related with three areas. The first is a smart environment. Second is remote healthcare. Next is precision agriculture. Okay, I mean this area, these areas which these are the areas which are already in discussion, already in research, and in few areas we have seen lot of research has been done already. Like precision agriculture means, I mean, depending upon the environmental conditions, your farmer will be intelligent enough to do the farming. So we will be helping with the help of our technology to help the farmers. Like we can use the Internet of Things to help the farmer to detect, I mean, to get the knowledge of the environment based upon the devices. Next is industrial automation, like remote healthcare. Okay, remote healthcare, like I mean, with the help of artificial intelligence, virtual reality, and wireless communication. You can see that a robot can perform the the surgery of a person remotely, even in the remote areas where there is not any availability of a doctor, or maybe sudden need of doctor is required. So with the help of this remote health care and with the help of this industry 10.0, will be helping the patient remotely. Now smart environment, okay, definitely it is needed for the industry 10.0. Okay, so this is again technology that holographic teleportation that we can see is a part of 6G, which is also a use cases of 6G holographic teleportation that we have already discussed about it. Then if we talk about the space connectivity, so this space connectivity is connected with the smart infrastructure, right? I mean, if you want to connect our system with the space, then definitely our system must be, smart enough, right? So to connect space, to connect our system with the space beyond terrestrial, so smart infrastructure is also required. Like, I mean, you must have heard about smart city. Okay, so I mean, we are evolving towards 6G. We have started to change our infrastructure, and we have started to evolve for 6G. So that's why we can think upon all these things, because we have already started to move in that direction. Autonomous vehicle, I mean, this is also a part of 6th generation. So these are actually the part of smart infrastructure, and these are the use cases of emerging 6G technologies. Okay, so in short, we can see that multi-sensory holographic teleportation is the use case of 6G. real-time remote healthcare, that I have already told you, like real-time doing any surgery or helping a patient diagnosis the problem. It can be done with the help of remote healthcare, and it is also a use case of sixth generation autonomous cyber physical system. Okay, autonomous cyber physical systems, this is also a very new area of sixth generation in intelligent industrial automation that we have already discussed, high performance precision agriculture, space connectivity, smart infrastructure and environments. So these are the use cases of sixth generation on which we can do the research, on which we can start thinking upon. Okay, so here we have talked about terahertz band communication. So this is, I mean, this you may be already knowing about it. Here you can see that this is a terahertz band on which we will be working upon. The terahertz band offers hundreds of gigahertz usable spectrum resource for wireless communication links in long, medium, short, indoor, and near field range. Okay, so this you can see that this is a range of radio waves. This is the range of microwaves. Then millimeter wave, which is actually used in the in 5G, and but here in 6G we'll be using this band, terahertz band. Okay, I mean these are the expected things. This yet to be an area of research. So, but yeah, for research you have to think first. Okay, you have to imagine first. So this is a kind of predetermined research topics that has been I mean designed by the researcher, by IEEE, on which we can start the research. Now here in this picture you can see the technological evolution of 6G, 1G to 6G, although I mean most of the part you already know. So if we go from first generation to sixth generation, you can see that in first generation we were using the FDMA. I mean it was totally analog in nature. Okay, so that's why we were using, it is also known as AMPS. So we were using FDMA technique in that. Moving toward, it was emerging in the form of 2G. So 2G is mainly you must be knowing about as GSM. So in GSM we use TDMA FDD. Okay, so here this TDMA is used. It's, so basically it was a turn from analog to digital. Okay, so next is the third generation. So moving from second generation to third generation, we have moved from TDMA to CDMA. Okay, basically WCDMA was used in the third generation. Next, we have already moved to towards fourth generation that we nowadays we are using in our mobile. So fourth G is basically deployed with the help of OFDM based MIMO and turbo coding IoT. These are the few features of fourth generation network. Okay, so we already know about orthogonal frequency division, multiplexing, and MIMO. Next, we have the 5G. Okay, so basically in 5G, we talk about the new radio and ELTE. So it is a combination of ELTE, which is enhanced LTE. Okay, 4G is also known as LTE. Okay, long-term evolution. So the enhanced version of 4G is known as ELTE. So 5G is basically a combination of new radio and the ELTE. Okay, 5G is basically a combination of enhanced LTE and new radio, and the technology that were used in 5G or that are used in 5G are OFDM based CMW and MMW, massive MIMO, LDPC, polar coding, URLLC, MTC that we have already seen. Now in sixth generation, so what is this sixth generation? It is actually future RET. Okay, so what is this? I mean 6G. It is basically we have imagined that it will be OFDM based, and or new waveform CMW and MMW. Terahertz will be used, extreme coverage, new NW topologies, further enhanced massive MIMO, enhanced URLLC, MTC, AI for everywhere. Okay, so the 6G will be a combination of new technologies and enhancement to bring big gain. Okay, so I mean, you can see the performance evolution of from first generation to sixth generation. So here in this slide, we can see the projected timelines for sixth generation and beyond system. Okay. Of course, whenever you plan something, then you have to put it with the help of some timeline. I mean, what will be the expected time in which we can expect the sixth generation. So here you can see that if you talk about the 5G starting from 2018, we'll be discussing about that 5G evaluation will be started. So here in 2019, release 15 was developed in 2018. So the evaluation of 5G was started. And here 5G PP phase 2 and NSF PAWR project were started. Then if you talk about 2019, release 16 was developed. In 2020, again release 16. So here you can see that by 2020, it is expected to have 5G everywhere. Now the vision of 6G will start from 2021, although it has already been started from 2020 itself, because the most of the information that I have put in this slide is from a paper which is published in July 2020 only. So I mean, you can imagine that whatever we are discussing, it's a future version actually, future vision actually. So I mean, by the end of 2020, we can expect the vision of 6G will start. So here in 2021, it is expected to have a release 17, which will be depicting about the 6G vision. Okay, so because officially by ITU or International Telecom Union, will be having the specification of sixth generation. So by release 17 and 18, your release 18, I mean the version of release 18 will be given, and then the main requirement of 6G, I mean based upon the environment and based upon the system, the requirement will be generated by the starting of 2024 or by the end of 2023. So again, a lot of study will be required for that. So that's why I'm telling you again and again, if you want to do research and if you want to publish more papers, then you can start thinking upon these key areas. I mean, Internet of Space thing, Internet of Nano things. So these are the very industry automation 10.0. So you can start thinking upon these areas for your research. So by the end of 2025, 6G requirements will be over, and then by the starting of 2026, we'll be having the 6G standardization. Okay, 6G standardization will be starting from 2026 end or maybe 2027 starting. Okay, again, I mean beyond 6G study will be there in the same year, and then specifications will be designed for that. So now here, okay, so now here from 2026 to 2031. Okay, so beyond 6G study will be there. And what about 6G? 6G evaluation will be starting by 2028. Okay, so here also again, as per industry effort, we can see that 6G test beds will be expected to design by 2027. Okay, so 2027 to 2031 we'll be expecting to have these 6G test beds. So I mean by 2031 we can expect to have the 6G as the market in the market. Okay, so I mean these are the projected timelines for 6G and beyond systems. We have discussed about the green energy. Okay, green energy, green radio in the 5G. Okay, so basically in green radio we have classified into two main parts by the efficiently utilizing the conventional energy, and to think upon the green energy part, which is actually energy harvesting. Okay, we have discussed about two type of energy harvesting. Okay, the first is environmental and the second is RF, and also with the help of smart grid improvement. So, increasing pressure resulted from large power consumption and more public concern of sustainable development. We have to think about the 5G, green area of 5G. The communication industry has set its stringent energy efficiency as a key objective of the 5G system. Okay, so energy efficiency not only of 5G, 5G and beyond, energy efficiency will always be a main area of research. So this area will never be faded for research. So energy efficiency improvement is a major requirement for industry. Okay, so also key enabling technologies that are vital on to the success of 6G and beyond systems are highlighted. 6G and beyond wireless systems will be largely driven by focus on wireless ubiquity, that is, the unrestricted availability of high quality wireless access. Okay, so 6G and beyond wireless system, it is driven by wireless ubiquity and unrestricted availability of high quality wireless access. You will never think about a call drop, you will never think about problem in the network if you talk about the sixth generation. Okay, what will be, whenever you have a seminar, you must have something take away from that. So I want to mention few key areas of research from this seminar that you can take away. The main research area is, the first is the energy efficiency and spectral efficiency. You can think upon the new architecture and deployment. Okay, so this is also a new area in which you can start your research. Then green energy exploiting. Okay, that energy harvesting, I'm again and again repeating, energy harvesting and smart grid. So these are also the research directions that you can think upon. Smart grid enabled network. Now whole 6G and beyond is the area to explore. 6G is nothing. 6G is something like you can start. So industry of the Internet of nano things, Internet of bio nano things, quantum mechanics, Internet of space thing, cube satellite, industry 10.2. So these are the few areas in which research can be done. Also, when you talk about terahertz communication, so to design system, to design devices for terahertz communication also will be area of research. Every device cannot work at terahertz communication system. So for that, we have to design that kind of antenna systems which will be working on terahertz communication. So that's why these are the key area of research that we can do. Okay, so these are the few research papers that I have used for this 5G. But yeah, so here I want to mention that this is the paper that I have followed, 6G and beyond. So if you want to do research, you can go for these two papers, the first one and the second one. Okay, so the second one is the white paper on broadband connectivity in 6G. So you can study this paper to study more about the 6G communication. Okay, so this is very latest paper. This has been published in July 2020, and this is also 2020 paper. So you will get a lot of knowledge about 6G and beyond with the help of these two papers. Thank you very much for patient listening. Any questions?
Thank you, Meenakshi ma'am. Some queries are written in the chat box. Start with
okay, ma'am.
What is industry?
Okay, ma'am. Let me see.
Oh.
Yes, ma'am. So yeah, I can see a lot of queries are there.
Yeah, started with the 12, 16. First query is there
Yes.
from
So
Ravi.
Industry 10.0 is a version of new version of Industry 4.0, in which each and every part of industry, like if you talk about manufacturing of a unit of something, so here every device will be automated. I mean, robots will be working for that. I mean, no human will be required for that. So everything will be you know uh, automatic in that. So that is Industry 10.0, and everything will be connected with the network, with the remote network. So one question is from Monica Thakur, ma'am. So, ma'am, is it possible the advancement in technology from 4G to 5G? Okay, also increase the health problems due to more radiations and traffic. Okay, so yeah, Monica, yeah, this is also my concern, because once I heard about sixth generation, so already with the help of evolution from 4G to 5G, we can see a lot of problems with our birds and animals. So yeah, this is also a key area in which we can start thinking upon the health issues. Even I have already mentioned this to IEEE also, from where I get this paper. Like we have to open a platform where we can involve our scientists also, to have a collaboration learning. I mean, collaborative learning. While we are moving from 5G to 6G, we have to think upon the health issues also. But let me tell you one thing: in 5G also, we need we work on the micro cells, and the antenna height is also very small, okay, as compared to 4G. So once your antenna height is small, when you work on micro cell, so it will affect a small area, small geographical area. So problem or issues comes when you have high transmission power, when you use high antenna, because high antenna will be giving you high transmission power. So that's why that will be a more problematic for birds and animals, as compared to when you use microcell concept. So in 5G we use the picocell and microcell concept. So of course, I mean, I cannot deny, if we move from 5G to 6G, so definitely we have to think upon the health issues also. Yes, ma'am. Yes, ma'am.
Ma'am,
Next
another
query
one.
can I take?
Yeah, sure.
So
Next one
what
query is,
is
yeah, what is channel bandwidth 1 gigahertz? Which band is used for 100 gigahertz?
So for 100 gigahertz, I have told you, like when we talk about sixth generation, we will be talking about the terahertz band. Okay, we'll be talking about the terahertz band in the 6G communication. Okay, whether 6G is for space applications? Yes, of course. 6G, I have already told you, like 6G will be not only working for terrestrial communication, we'll be using the Internet of Space things there. So definitely, it is expected that we'll be having a communication between terrestrial communication and the satellite communication with the help of cube satellites, we can say. With the help of cube satellites, and by utilizing UAVs and the cube satellites, we can get to the space communication and the space applications with the help of 6G. Country has got most balanced 5G spectrum. I cannot get the question. Most balanced 5G spectrum, what does it mean, most balanced?
Excuse me, ma'am.
Yes.
Yeah. It's here's Monica Thakur that I have asked question about the health issues, and you told
Yes,
me
Monica.
that the antenna height will be small
Yes.
to decrease the health issues.
No,
But
no, 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 not Monica, not to decrease the health issues, because in 5G, we talk about the microcell concept. Okay, microcell and picocell
okay,
concept is used. It is not to reduce the health issue. It is just the way by which we can deploy the 5G. Okay, there are few key technologies that used in 5G, which are that picocell concept is used, beam forming is used, okay, and a small antenna height, okay, and it will cover very small area. Yes, Monica.
So that means number of antenna will increase in 5G or 6G.
Definitely. I'm not talking about 6G, but in 5G, because 6G technology is yet to be deployed. It is under
Okay.
research. So it is not decided. I mean, what are the antenna height will be used? What kind of antenna will be used? I mean, this is a kind of topic which is under research. Even the specifications that I have already shown you in the KPI form, it is yet to be finalized by ITU. Okay, I have already
Oh,
mentioned that these specifications are not finalized by ITU, because ITU is the governing authority of all these specifications. So it is
yes,
yet to
ma'am.
be finalized by ITU, but yeah, it has been floated in the market so that research can be started and people can start thinking upon the 6G. Yes.
Oh, okay. Thank you, ma'am.
Okay. How 5G will affect the IoT? Okay, so IoT, I mean, 5G is already under process and it has already been deployed. So, IoT is an application, Internet of Things. I mean, you must be knowing like Internet of Things. I mean, we will be connecting devices, multiple devices with the help of Internet. So, 5G will be giving you much higher speed. Okay, so much higher speed, much higher data rate is given by the 5G. So when you connect multiple devices on network, so definitely the connectivity of these devices will be more if you have a good data rate. So definitely this IoT is connected with 5G and it is working very well with the help of 5G. I mean, if we deploy 5G in whole India, then I have already given you the example, like our farmers can use this IoT for their agriculture purpose also. I mean, with the help of automated devices, they can detect the intelligent. They can intelligently detect the environment and do the, you know, uh, you know, uh, planting and everything. You know, sensing the environment can be done with the help of IoT very easily. So, of course, if we have 5G, it will be helping IoT a lot. Ma'am, any other query? Yes, from Richa. For 5G communication, what will be the better gain, or how can we improve gain and better bandwidth? So, what kind of gain, Richa, you are talking about? What gain? I mean, are we talking about antenna gain or system gain?
In terms of dB, she written, ma'am.
So that is the unit, but what gain? Overall gain of the system.
Yeah, she written overall.
Okay. Overall gain of a system. How we can improve the gain and better bandwidth. Okay, see, if we talk about the gain of the antenna, I mean, that will be depending upon the antenna size. If we talk about the gain of the system, so definitely it will be the gain of the system will be depending upon the type of environment, in what environment we are using, and what are the environmental conditions, like what will be the interference, what will be the distortion, what will be the fading, everything. So that we have to consider, and that way we can think upon the overall gain of the system. Okay, so I mean, without having the knowledge of the environment, we cannot predict what will be the gain. So first we have to think upon what kind of fading channels are used, what kind of environment we have considered. Ma'am, any other question?
Thank you, Meenakshi, ma'am.
Thank you, ma'am.
This session is so nice and very informative. Payal, ma'am.
Yes, ma'am.
Yeah.
Dear participants, kindly turn on your cameras for a group photograph. Ma'am, you also please turn on your camera, Meenakshi ma'am.
Yes, yes, I have turned on. Can you see
Yeah.
me?
Yeah. Thank you so much, ma'am.
Okay.
Thank you so much, Amal.
Thank you, ma'am. One more thing I want to mention here. If anyone want to do research in the field of 5G or energy efficiency part, so they can contact me. Ma'am, you can provide my email ID to the concerned person if anyone wants to do research in energy efficiency part, because that was my area of research of my PhD. So if anyone want to continue or want to start his research, yeah, I guess Richa is need of my email ID. So I can write here in chat box.
Yeah, ma'am.
I've written two email IDs. Anyone can contact me for any research or any query regarding 5G or energy efficiency. Thank you very much, ma'am.
Thank you,
Okay.
ma'am.
Okay,
Thank you, ma'am.